Okay. Yep. Okay, so I'm Cameron, and this summer I was working on modeling dispatch of the Railbelt. So Alexis and Leif already talked about this a little bit, but I'll give another summary of the Railbelt. It's the largest regional electric grid in Alaska, and it spans from Fairbanks to Homer. It serves an average load of about 600 megawatts, but spans about 700 miles. So it kind of has a large geographic area with a relatively small average load. And and because of that, it kind of has limited transmission infrastructure and a lot of installed generation capacities to keep reliability standards. And the Railbelt Decarbonization Project aims to explore decarbonization pathways for the Railbelt, and it is hopefully going to help utilities make planning for the future of the Railbelt. And then kind of the bigger picture is to demonstrate the opportunities and challenges of decarbonizing isolated regional electric grids like the Railbelt. And so my main role in this project was to build a production cost model of the Railbelt using Plexos. And a production cost model is basically a model of an electric grid that takes in data about all the generators and constraints on the transmission system. And it optimizes which generators should turn on and when in order to minimize cost of serving electricity to meet load. And this production cost model will be used to analyze the 3 decarbonization scenarios of the Railbelt. And since it's a cost model, it will be also used to evaluate the economics of the 3 decarbonization scenarios. So the methods that I used was, first, I had to learn about the history of the Railbelt and all of the utilities that are in the Railbelt and become familiar with all the generators and the transmission system, and kind of learn about energy in Alaska in general and where everything is located and how everything works. And then I identified the data that I would need for the Plexos model, and then had to request that data from the utilities. And I sort of filled in the gaps with the data with publicly available data from FERC and the EIA. And then throughout all of that, learning how to use Plexos and creating a user guide that lays out all of the different generators you can model in Plexos and kind of gives tips for future users on how to use Plexos. And then with all of that, I built the production cost model in Plexos, and my goal is to compare my results with the actual dispatch of the Railbelt in 2021. So the data that I had to collect, first, I guess like the main data is the electric load from each Railbelt utility so that you can make sure you're having enough generation to meet demand at each hour. And then I had to collect a bunch of data about the generator characteristics. So that includes the capacity of the generators, the ramp rates, the heat rates, and then also the profiles from all the renewables like the solar and wind. And then I also had to model the transmission system constraints, which right now my model just has the Alaska and Kenai interties modeled. And then I also I needed to collect data about the reserves. And reserves are basically just spare generation capacity that can come online fairly quickly to meet sort of unforeseen changes in load, or if something breaks, you need excess generation to come online and make sure you're still serving electricity. And then I also needed fuel cost and fuel availability data. And like I said before, some of this data is provided by the utilities, and I'm still getting more and more data. And then I've been filling in the gaps with publicly available data. So here's a graph of 5 summer days. So you can see the summer load is about 600 megawatts, a little under 600 megawatts for these 5 days at least. And you can see we have a lot, you can't see on the bottom, but the orange is natural gas, the gray is coal, this red is oil, the blue is hydro, the green is wind, and then the little tiny bit on top is solar. So you can see we have a lot of natural gas, quite a bit of coal, a little bit of oil, quite a bit of hydro, and then also solar and wind. And then you can also see in the winter, the load jumps up a bit to a little over 700 megawatts. And you can see similar sort of patterns with the different types of fuels. But you can see the gas is sort of following the load more to meet these like higher peaks in demand. And so this is what I have so far to compare to our actual generation data from the Railbelt. So, and these are also comparing different years, but I actually just updated it with 2021 data this morning and it is looking better, so that's good. But the blue is, yeah, so the blue is my model in Plexos, and then the red or orange is actual generation data from NREL. And so you can see this gas combined cycle, that's the most efficient type of gas plant. So my model is kind of over generating on the combined cycle plants because that's the most cost effective. So yeah, the next steps are to kind of look at all the generators and see which ones are not performing right, and then make sure that these line up better. Is that it? So next steps, like I said, finalize the model with the utility provided data, update the loads and all of the data with 2021 data so I have a more accurate comparison. And then in the future, build upon the model to analyze the decarbonization scenarios. And one of the many lessons learned is that modeling and understanding the reserves that I talked about can be very complicated. So I'm still learning how to do that and learning how all of that works in the Railbelt. And thank you. Any questions? Lindy? The limitation and strengths. I would say the strengths, at least for me, is that it has like a pretty good user interface. So you're not really doing a lot of like back like coding, which I like. But I think that can also be a limitation because then you're kind of just inputting this data into the software and it's hard to tell exactly what it's doing. But Plexos has a pretty good like documentation. So with the user interface, you can kind of click on any of the things you're modeling and it gives you a pretty good explanation of what it is. So then from there, you can figure out what Plexos is calculating. Mari? Dane? Whoever has the microphone.
I have the microphone also. Okay, so my question, I've always kind of wondered about production cost models. Is it just operating costs or do you also enter capital costs and like, does it do stuff like depreciation or I never really understood that. And that I partly asked that because sometimes we always refer to Homer as this like little mini production cost model for microgrids, but it could be that Homer does more if PCM models don't do the former.
Mm-hmm. Yeah, so the production cost model does include like it doesn't include capital costs unless you're doing the more like planning for the future where you're doing capacity expansion where you're seeing how much would it cost to build a new plant. But it does include like yearly operation and maintenance costs. Does that answer your question? Yeah. Yeah. Mm-hmm. Yeah. Dang.
So it might be just an artifact of how the things were done, but it looked to me like the hydro was pulsing through the day like a solar. I would expect a solar thing to go. What is that? Is that just an artifact of the thing, or are they actually ramping up and down the hydro?
That's a good question. We have to look more into the hydro and like how it's dispatching at each like hour and day compared to the actual hydro. But in Plexos, what it does is it's saying like what's the cheapest option. So the cheapest option is probably to dispatch all of the hydro when the load is highest so that you're not having to run like the peaker natural gas plants that are really expensive. So I know for the Railbelt hydro plants, they have like a plan of when they dispatch the hydro to make it most cost effective. But as far as like if that graph is exactly accurate at each hour of the day, I'm not sure, but that is something that I'm going to look into.
And I'm just going to give a shout out because you might not have seen it, but Steve wants to recognize you as our decarbonization hero. I concur.
Thank you, Steve. Any other questions?